Okay, so in P6, we've been working with rational expressions, and a lot of times when they give us something new, they always want us to be able to simplify, and then they want us to be able to add, subtract, multiply, and divide. So we talked about simplifying rational expressions in the last video. Now we're going to talk about multiplying rational expressions. And you might say, well, why aren't we starting with addition and subtraction? Turns out that really the multiplying and dividing is easier than the adding and subtracting. So we're starting with the easier part. So when we multiply rational expressions, it's kind of like you're going to have some polynomial, times a polynomial over a polynomial times, another polynomial. Oops. They're all in x over another polynomial. Well, you've got to factor each one of those. And then you're going to see if anything can cancel. You don't want to actually multiply straight across because you're going to get these huge polynomials that would be hard to deal with. It's not that it would be wrong, it just is going to be easier if we do them individually. So first step, factor all numerators. Numerators, can't spell numerator. And denominators. And then step 2, cancel. Step 3, you got to write your final answer. Now, think of an example. Maybe you had 3a over 2b times 4b over a. Okay, so the numerator is already factored. Those are factors, and the denominators are factors. So what could you cancel? Well, you could cancel the b's, you could cancel the a's, and 2 goes into 4 2 times. So what do you have left after all that? In the numerator, you have 3 times 2. In the denominator, you just have 1. So the answer is 6 in that case. Okay, so that's kind of like a mini example. All right, now we'll have a bigger example. So sometimes you don't have to factor because it's not factorable. So we have 4 pieces to this multiplication problem. We have the first numerator, the second numerator, the first denominator, and the second denominator. And so we're going to factor what we can factor. All right, x minus 7. Yeah, that's not going to factor. It's just a binomial. It's not the difference of squares or anything. It's just x minus 7. I do put in the parentheses to help remind me that that is a factor. In the denominator here, same thing. It's a factor of x minus 1 times, dot for multiplication. Now I want to factor x squared minus 1. That's the difference of squares. Difference of 2 squares that we were learning about when we were factoring. So it factors into x plus 1 times x minus 1. And then I've got a denominator here. That's a GCF. There's a greatest common factor of 3. So I'm going to factor out the 3 and have x minus 7. So I've done all the factoring that I can do. So really you're getting like 4 factoring problems all in one problem. That's the hard part. You have to factor each numerator and each denominator. Now the first term, the numerator and denominator, they didn't factor, so that made it a little bit easier. Okay, now we're looking to cancel. So anything that has a factor the same in the numerator as the denominator. They don't have to be across from each other. They could be on top of each other, but this time the x minus 1s are canceling and the x minus 7s are canceling. So what's the answer? What do I have left? I have x plus 1 over 3. And that's going to be my answer. You might have a question why I use an arrow there and not an equal sign. I don't want it to look like an equation. We didn't have an equation to start with. So it's just saying, hey, I'm going to put my work over here to the right. You could have put it underneath. That would have been fine.